Hello and welcome to the New Space Vision podcast sponsored by LiveView, where we discuss new space technology, finance and innovation with executive founders and more exciting people from the startup and new space ecosystem. I'm Sven Shivara.
And I'm Daniel Seidel, and together we are the founders of the Earth observation company LiveView and New Space Vision. Today we are very happy to welcome you, Lukas Werling. He is the co-founder and CEO of ISP Tech, a company developing non-toxic propulsion technology to get satellites into the right orbits. We're going to talk about this in a bit more in a second, maybe also to keep it there, right? But the first question, Lukas, do you like fire?
Definitely. From my childhood onwards, I was keen to fire. So that's why I took the job at some point.
So you really like fire. Did you play with fire?
Yeah, as a child, people always say I will get a pyromanic or something like this because I was playing with the candles. I mean, it's Christmas, it's like the Christmas time is coming. So and when I was a child, I was playing always with the candles and people watching me. So yeah, I think you have to get a rocket scientist, which I then went later on. I think that's an important skill you have to develop.
So it was also very early interest into space and engineering.
Definitely. I mean, what I remember well from my early childhood is when I love Star Wars. Up to the day, you see also the Millennium Falcon here behind me. It was it's really my head I get from my PhD, All my colleagues at DLR built it. So I really this was saying the first connection was like with the movies, Star Wars, and then also ET in those times, but also a lot of literature, sci-fi literature was always really, I was keen to reading a lot of books when I could start reading about rockets, about other planets and so on. That really fascinated me, how mankind would evolve in the future and expand to the universe. This really from my childhood on. And this was if you now look back, I think it was quite clear that I would take a job in this sector. I would operate in this sector. And this was, I have some nice pictures where I built some Lego space shuttle launch pad. So from when I was a little child. So that's really interesting.
That's something which we have in common. I think Star Wars also sparked my interest in space. So I think maybe it did for many. I would be keen to understand like what the percentages of people which are now working in the space industry, which have been excited about this from science fiction. But from these very early days, you continued in that field, and that's also what you touched on. You also write on your website that 10 plus years of R&D paved the way for two ISP techs, Propulsion. So what have you done before starting the company?
Yeah, after my studies, I did conventional mechanical engineering in the southern of Germany. But as I had those, enthusiasm about space, and propulsion in general, I said, okay, let's apply at DLR, the German Aerospace Center in Lampoldshausen, where the European test site of all the rocket engines are, and that I want to work there. And I had a professor at university. He was former head of DLR, director of DLR. So he was already quite senior. And I asked him many times, I want to do my diploma thesis at the end of the studies at this DLR site. And then someday I was in his office. He said, okay, I will call the institute director, which then was my later boss. I have a student here. He does want to do propulsion, and do you have a thesis for him? This was in 2010. So then I started at the German Aerospace Center, did my thesis there, and then afterwards also started working at DLR. I was many years responsible for a research and development test bench where we tested all different kinds of propulsion rocket engines, from saying the Newton class up to kilonewtons, larger engines. And this was always a lot of fun, a lot of interesting, but also, you have to be careful. It's rocket engine and rocket science. But we came in contact also with many of the European players. We had EU projects, we had DLR internal projects, ESA projects, where we were all involved with the space ecosystem. And it was always in my career, the red thread about those non-toxic propulsion, where my first project at DLR was already about that. Yeah, and then was working there many years, project manager, group leader, did my PhD, as mentioned, in green propulsion. Afterwards came back to that. I was staying at DLR, but then I took over the research group and got deputy head of the department. At this point, I was talking to my co-founder, let's found ISP Tech because we have so great technology and we see the market shift is there. We have so many problems already solved where other companies are still struggling with. And we see that we have now the opportunity. And this was then in 2023 in summer when we founded ISP Tech.
Maybe before we go and double click on this, ISP Tech What does ISP Tech stand for?
I mean, our full name is InSpacePropulsion Technologies, so it's like quite descriptive, you know what we are doing. But I mean, we are the nerds, you know. The ISP is the specific impulse, you know, the efficiency of your rocket engine, so to say. So we said, okay, we will name us, and then you can always do the abbreviation, which is just an ISP Tech.
Yeah, and I think this is very cool. I asked.
I bet ESA Aerospace had the same these discussions when they started the company.
Yeah, Daniel, exactly. I think we talked about this because
we talked about
at some
this,
point. Yeah, at some point, Josef told me, we want to name us initially ISP Technologies, but then changed the name because he said, it was too nerdy. I was like, okay, thank you.
And Josef is the CTO and co-founder of ESA Aerospace. Yes, maybe he has a comment.
Exactly, yeah. And then, I mean, you were, I think, more than 13 years in Lampoldshausen. And I think during my studies, I visited Lampoldshausen once, and I think it's one of the most exciting space locations in Germany very few people know about. Can you maybe explain a bit what was your environment over these 13 years? Because I know, that the people who live in Lampoldshausen, they are used to windows which are somehow vibrating. What do people do in Lampoldshausen?
Yeah, exactly. When I had, as a student, I had a room in Lampoldshausen, and so the room with flat when I was a student, and then always the people who rented the flat to me always said, did you test today? Because our windows were shaking, just exactly as you said. So Lampoldshausen is like 30 kilometers away from Heilbronn in the, saying northern of Baden-Württemberg in Germany, so south of Germany, but there's some region, and it's like laying in the woods, quite remote, because you test rocket engine, not only the ones we are doing, like in space propulsion, but also like the Vinci engine or Vulcan for Ariane 6, Ariane 5 before, and for all the large rockets. And therefore, of course, you can do it in a big city or next to a big city because of like the hazard zones and everything. So it's quite remotely in the woods, but in the north of Heilbronn, and quite good connected anyhow, despite dying in the woods to the highway. This is quite nice.
Yeah. And one thing I remember when maybe you know this company Spin Launch, right? Which is doing this rotation and then flying up. And in the animation, the control center was directly next to it, right? But then when you're in Lampoldshausen, you see that even at the test facility, right? Like where the people then control it, it's further away down in the ground, right?
Yeah, Americans have a higher risk appetite.
Yeah, have a higher risk appetite potentially, yeah. But
yeah, I mean bunkers like next the test, the control rooms are just some step away, but there are bunkers where they control the rocket engine test fires, and there's like the safety radius around and all the woods around, like there's control that no hiking guy goes in there when there's a large test. So that's
Only the crazy ones try it. But maybe before we go into the founding of the company, because I think it's such an exciting topic. Was there anything in these 13 years where you say, "Oh, this was crazy"? This test was crazy, or something went completely wrong?
I mean, honestly, there were always things which went wrong. I have to think about what I can say. I don't want to blame anyone. Yeah, I mean, you can imagine. I was head of the test facility for 9 years. And we did a lot of really initial research projects. And there always, the danger was that our question was always, okay, in the worst case, what can go wrong? Like the scenario was always, we have a tank filled with propellant, experimental propellant. What happens if it blows up? And therefore the system has to be designed. So we had those incidents where we had unintentional ignitions or rapid unscheduled disassembly, like the saying is in the space sector. And the highest priority was always that no one gets hurt. And I mean, the test benches are designed for that. They have thick walls. They have like thick concrete walls with irons in it. And we had several incidents where then engines did blow up because it was not out of scope. And it was always like, of course, frustrating, but also when you feel the energy which is in the propellant and the engines, which is consumed in this short amount of time, you always feel a lot of respect for the physics, so to say, which is behind that. And honestly, we also had like situations where we had a little bit of luck as well, because there was something happening which wasn't anticipated in all the risk assessments, and therefore like the thick walls and the remote control, and so is exactly to avoid any injuries.
Yeah. And maybe let's talk about the funding process, right? So when was the first time you thought about, okay, I want to start a company, and then maybe you can walk us also through the journey of doing a spin-off of the German Aerospace Center DLR.
Because I think that this is super relevant because in Germany there's a big debate is how do we get all the great science and research which we have in a lot of the institutions, not only in Germany, but across Europe, out into the real world, so to say, and into the hands of actual customers. And you're a prime example how that might happen. I think there are a lot of people curious to learn more about that how that worked.
Definitely. I think the first thing which, I mean, when I studied typical mechanical engineer, I wasn't even aware that you could found a company. I mean, for me, founding a company was like an engineering office, something like this. To have like, this was like the only thing I had in mind when I went out of university. And then especially in the space sector, you know, like 2010, there was no new space in Europe, at least not. So it was very, very far away. I honestly did not think about it for the initial years of being at the German Aerospace Center. What I think, so that brings me to the first point, is that you have to be aware of it. You have to be aware, okay, this is like an opportunity to found a company in a specific sector or where you have expertise or where you love. This you must know, because in the conventional, like the education at the university, this is not, I mean, in my times, it was just not included, or was not the case. And then at some point, what we had at DLR was that there was a push more from the political side, that more and more spin-offs got favored or got more support. And a very specific scenario was, we had in our department, you know, also know the guys from Heimpuls, the founders. They were now in the same department as we were, as Felix and me, my co-founder and me. And then they were founded Heimpuls in 2018, and then said, this was the first time I really realized, hey, you could found a company and change something in the space sector. You don't have to stay like the scientist, or you don't have to go to a big corporate. You really have the opportunity to change something, to really make something out of your research. This was like what I realized when I started to realize that this opportunity, this possibility exists. So the awareness is a big point for me. And then also the support program, the second one, because now there are more and more of those transfer officers aware of that they need support the scientists to give them the opportunity to spin off. In our case, a huge enabler was a spin-off program we were in. It was DLR is part of the Helmholtz Association, so the German Aerospace is part of that. And there's a good established spin-off program. We applied for that, got granted, and the transfer there was like, it was similar to Exist. A lot of people know this Exist program, where you still are employed at a research institution, but you can already operate as company and found the company in the program. This gives you those initial kickstart. You don't have to, you don't get out of the university or your research institution without a salary and with nothing. So you just you have some time to prepare everything. This was really nice.
Nice. And was it a smooth sailing, or were there some challenges along the way? And maybe also like, like having a fixed salary helps you to some extent, but what you're dealing with is actual hardware. And so how did the initial financing happen? What support did you get there?
Yeah, we raised our first round in May, end of May, or summer 2024. So like 1.5 years ago. That means we founded in 2023 in summer, and then had still the program running. But with the foundation, even beforehand, we looked for investors, because we said, okay, we are a deep tech space hardware startup. I don't have so much money on the bank to fund the company, and the grants are also not an opportunity because it takes forever, and we want to change something quickly. So that's why we looked for investors. And initially, of course, as a typical long-term working in the space industry, but have no touch points with any of those investment related topics. You have to dig you in. You have to do a deep dive. You have to understand how investors think, how everything works. And this is what we then initially did, to get to events, understand what's important, understand how to build a company. And this finally then resulted in our first funding round, which was nice, because this initial funding from Helmholtz was just more or less our salary, because then we could go to some travel expenses, but not very much some small amount of hardware, but not the big ones where we could really develop something.
Maybe one final question on that before we move on what the company actually does. So how does IP transfer happen? Because like this is the biggest question, right? And where we have seen like many weird constructs in the past, because obviously you've done a lot of research at DLR and potentially some of the IP also is now part of the company. So how did that work?
To be honest, we like negotiate with from the first outreach to having a signed license agreement with DLR. It took us, I think, 10 or 11 months. So it was quite a time, and it was good that we started the process early on, so that we had after foundation quickly the license agreement. So what we did, we have a exclusive license agreement on using the technologies. So we can't. As company, we have those exclusivity as DLR spin-off, and this was really important for us also to attract investors, because if you just don't have no IP or if you have just a non-exclusive license, it just doesn't work. And also DLR does not take a stake in the company of their spin-offs, which is quite nice, because also this can diminish your attractiveness for investors. But it took some time. And still, what my wish would be that the research institutions, the university, understand even better, like the how it works for the startups, how they can raise funds, because there are a lot of deep tech founders, as you mentioned, from going out of university or also the research centers. And if you have like a license agreement or no license agreement or a weak one, you will never raise any money. And people in the transfer office are just not aware of that. If they want to start the companies and they need money for their deep tech case, they just also need the possibility, the framework to attract private capital.
100%.
Did you have any supporter? Because I mean, we also just a couple of weeks back published the podcast with Max Gulde from Constellar. He was at the Fraunhofer. He was, I mean, was he diplomatic? I mean, I don't want to judge, but I mean, he was very honest about the challenges he had in the journey. Yeah. And now, Constellar is also a success story. So yeah, did you have any people supporting this and enablers during the journey?
The first point I wanted to mention, if Max was not there, I would recommend that you invite him to the podcast. Okay, I can just cross this from my list. So to be honest, with Max Gulde, we asked him. We know that they were a Fraunhofer spin-off. He was also part of ESA Business Incubation Center, where we also were part, and he had a speech there once. And then I asked him, hey, Max, this was our initial contact shortly. I mean, in those spin-off process. And I said, Max, how did you manage it with the IP transfer? Because we are struggling, we are having the conditions. And then he gave us some advice, and I asked him several times, what do you think about this and that? So I was really thankful that he gave us some advice, because otherwise it would even have been harder. And I know from our side, from the supporters, so this founder advice was quite important from also saying university or research institution spin-off. But on the other hand, what I saw in DLR, there's a mind shift taking place, and we have a specific section where they foster those spin-offs. And we also at DLR have one of the directors of DLR is also the transfer director. And we had then also a call with him and said, okay, what can we do about the license topic? And then he really helped us and said, okay, we will find a solution. So this was a point which really helped us, so that the mind shift is taking place, and there are people inside a large organization which really support you with some influence. Yeah, but still, I think this mindset of the people the lawyers which do the contracts, the license agreements and stuff, is different to the people who want to foster startups, even in the same organization, because there are different sections, departments, and so on.
Yeah. No, but I think that this mind shift is super important, and this is exactly what needs to be accelerated. But I think like people are curious, like what IP did you get out of it, and what did you made out of it? So, yeah. So what is your company doing? What are you selling?
Yeah. So ISP Tech is building and selling propulsion systems for any spacecraft. So what we provide a mobility in space. A large rocket is there to bring a satellite up into space. But once the satellite is in space, it has to be mobile, move around, get from A to B, change orbit. And therefore, the satellite needs a propulsion system. And that's what we are providing.
And so we Morpheus Space, and here a shout out to Daniel from Morpheus Space. He's promised us also to come on the podcast. But obviously, Morpheus Space is another German company which does this, and there are a couple of other companies across the globe, right, which do something similar. So where are you special, and how do you differentiate? Let's say, for example, from a company like Morpheus.
Yeah, first of all, Morpheus is doing electric propulsion. So we are doing chemical propulsion. The key differentiator is like chemical propulsion is the more powerful, much more thrust. For if you want to be very fast and agile in space, you need chemical propulsion because the thrust levels are 1 million times higher than for electric propulsion. Electric propulsion, what Morpheus is doing on the other side, is very efficient, like 10 times more efficient than chemical propulsion. So what we're seeing that for specific applications, there is a use case for those electric propulsion solutions for station keeping of a satellite, for example. But conventionally, like a chemical propulsion system can do every maneuver in space. It may be not so efficient, but for any rendezvous and docking, for landing on the moon or Mars or on a celestial body, for example, like with rendezvous and docking, if you see the Dragon capsule docking to the ISS, you see all the thrusters firing, and that's chemical thrusters. Or, you had also Sebastian here on the podcast for Atmos. They want to do re-entry and they want to do it quickly and precisely, and then you need a chemical propulsion system. And in addition, anything you want to do fast. If you go from orbit A to orbit B, you need chemical propulsion system.
And when I look at Sven's computer, you more than 1.5 decades ago. What is that on your screen? What can I see there?
So, I've also had the idea one day to become an engineer. Luckily, I haven't become that because I'm way too impatient for that. But I wanted to develop a horizontally horizontal starting space glider called the Argonaut. And that one back then I had the idea to use hydrogen. I hope that's how it's being pronounced in English. And now I can't pronounce the other thing because I only have it here in German. Stickstofftetroxid as propulsion. So I've heard that this is highly, highly toxic. And you said you're using environmental friendly propellant. So could you maybe tell us a little bit about like that bit? Like what are you burning up?
Yeah, in general, that's where we started to research. We started to research on alternative propellants, which are not so toxic or much less toxic, so-called green. It's always like in our bubble, it's the green propulsion. It does not mean it's carbon neutral or something like this, but it means it's less toxic, easier to handle. And the thing about those propellants is not, from a commercial perspective, it's not about the toxicity, but about handling, about testing, about everything, which is much more expensive with a really toxic propellant. And as also like in other industries, like in the automotive industry, the propellant is always connected to your engine. So it does not stop with the propellant. You need a suitable system to burn and fire the specific propellant. And our journey was like at the beginning, research on propellants, then developing thrusters, and now building the whole propulsion system for burning those non-toxic and much greener, so to say, propellants. Regarding the hydrogen and NTO is the abbreviation, Daniel. So you can just do. So those are the conventional propellants, really nice. From just a performance point of view, and many others, you may love them, but very expensive, carcinogenic, corrosive in parts. So not some substance you want to handle with. That's the main topic there.
One bottom line about new space is you don't look at like the unit specific performance of an element, but of the entire system efficiency of something, right? Like not only, how good can you do this or how reliably can you build this one single piece, but how expensive is it if you look at it from a systems point of view, and how efficient can you do this? So super, super cool. Yeah.
So basically, we now have a bridge from. Lukas, go for it.
Yeah, exactly. I just wanted to add. That's typically when we talk to customers in the new space sector. I know the classic space. We worked with them at DLR, and it's not about having the last percentage of performance. It's about a new space player doesn't care if I have 3% more performance if the system takes years to be delivered. And like the cost are 10 times so much. So this is, that's not a requirement from the new space market. And that's definitely where then all those green propulsion comes into the game.
Yeah. And we now in this podcast got the bridge from your Jugendforscharbeit. You won a prize there, right?
Yeah. Not a scientific one, but the mayor of my town was very excited about the space glider I wanted to build there.
So it was called Argonaut, when you were 15, 16?
For 15.
It's funny because now just recently, right, we have heard about the first German astronaut who will orbit a moon, right? And the moon lander program is also called Argonaut. So you should have reserved the right, but too late. So maybe Lukas
did see it already in those times. He saw it that it will come this way.
So also the Argonaut, also a potential customer for ISP Tech?
Yes. Definitely. It would be great to equip some I mean, the commercial perspective is one side, but from a space perspective, space geek perspective, of course, it would be cool to have like equipped a lander on Moon, Mars, or anything. This would be really cool.
Yeah. So over the last 2 years, you had 1000% growth based on LinkedIn data and your team. I mean, when you
that's
started,
nice. From two founders to okay.
So can you share a bit? Your team is growing a lot, right? So more than 25 people, I think.
Yeah, if you count the heads, if you do the head count, we are nearly 40 people now because we have a lot of part-time and students, and with a strong connection to the European or saying aerospace industries, also from our heritage from DLR. So it's always great to have some diligent students there.
And where's that growth mainly coming from? What is the driver for you?
I mean, currently we need a lot of people. We are currently building the first systems for our customers and getting from a well-working prototype, which we had at DLR, up to a space-qualified product. And that's our main task on the technical level currently. And of course, we are on one part also developing stuff further, which we see there is a significant customer interest. This is a very good topic, for example, for some thesis work for some students, but also we are developing and qualifying those products, which is our core focus for the ongoing customer project.
Yeah.
Okay. And maybe if you say customer projects, what are customers of yours? Maybe existing customers and ideal customers. So I've seen that part of your team was at the Space Tech Expo Europe, which is a big space conference here in Germany. Like, what kind of companies are your colleagues there talking to get them as customers?
Typically, all the satellite manufacturers. So the first systems we will fly will be on CubeSats, aside with the system we built for Atmos. So CubeSat customers, then small satellite customers, and also later on the larger players with their large satellites. What we already spoke about, landers or capsules, something like this. So that's the whole range of customers we are addressing.
So if you're talking about CubeSat customers, right? Like people sometimes maybe have still believe that a CubeSat is only one U size, so 10 by 10 by 10 centimeters, let's say. But you have a system which is 2U size and which would then fit into a like 6 or 8 or 9U CubeSat based satellite, right?
Yeah. What we're offering, what we're having is the smallest system we have is a 1U, as a 1 unit size system. That's a cold gas system. Here we are following the approach, have it very simple, very reliable, not complex, and cheap for a CubeSat. So this is a cold gas system. Then we have the 4U system. It's 4U size. It's for like a 16U CubeSat with a chemical bipropellant thruster and also additional cold gas thrusters. And then, of course, we go upwards to the small sat range. I can show you here. I have always my thruster here with me. That's a 22 Newton thruster. That's one of ours. And you see it will also saw some fire. And that's here standing on my desk. I can send you some mock-ups if you like.
It's interesting because you have just shown the thruster and you had your Argonaut, but I was I focused on aerodynamics during my space engineering. I was in the wind tunnel at BMW. During that time, working together with former Formula One engineers, we also thought about launching a company for 3D printed thrusters, etc. I think when we met last time, I also shared it with you that I'm super happy that someone now is doing it, because for me it also made sense. But that was 2015, 16, where I had the feeling it was a bit too early. Because the demand was not there, right? That's why at the end we started LiveView, right? Not a hardware company. So I'm really happy to see that. I think you wanted to comment on that, right?
Yeah, exactly. I mean, that's completely, Daniel, what we saw. We couldn't have founded ISP Tech 10 years ago because the additive manufacturing technology was not as advanced. We need additive manufacturing for key elements of our thrusters and propulsion systems. Without those technology, I mean, conventionally manufactured the thruster it would be incredibly expensive and complex. So this is really an enabling technology. So the additive manufacturing was an enabler for us. And I mean, as an engineer, I love the flexibility it offers, definitely.
Yeah, and also, right, customers coming together with the developing technology. And I have to say, it's pretty impressive that you already have 2 products available on the market right now, and seems that 2 more are coming online over the next 12 months. So that seems to be covering a wide range from 0.5 Newton all the way up to 400 Newton, right? And that gives you also a lot of Because what I'm always thinking about how I would assess like startups which are building subcomponents for satellites. And one question I'm always asking, how many buyers are there? But if you can like cover that wide range of applications, then you can actually sell to most of the market out there, right? Which I think is super compelling.
Definitely. And I think you asked about the USPs, and that's a differentiator, I think, because we had a huge unfair advantage. Like the trust and the technology was quite mature when we spun out. I mean, we put a lot of efforts in many years of development in it. And this was the first one. And we already understood from the market perspective that you don't win the game with just one thruster or one propulsion system. And we see a lot of companies out there offering just one specific thruster for one specific application. And therefore, I see you can build a small business out of it. But if you want to change something and really disrupt the market and get a real market opportunity, then you have to offer the whole range for the customers. So from the small ones up to the big ones, and to have it in a convenient way.
I'm really excited about that because I mean, Sven and I also about our company, we have a lot of discussions, right, with vertical products, but an underlying common platform, right, which we use to launch new products. So what for you is the connection from 0.5 Newton CubeSat to 400 Newton? What is the common thing you can now benefit from?
I mean, the common thing is when you think about a product portfolio is always like the experience and the know-how and the infrastructure you have for testing. You have to do every thruster has to get through acceptance testing, and if you have the infrastructure on place, you can use it for different thrust sizes. I mean, that's also done by conventional propulsion companies or space industry. And of course, we also have like the design with the additive manufacturing. You can scale a lot. I mean, which would not be possible or how much harder for conventional manufacturing technology. You can say, okay, I have a working design of my 22 Newton thruster, for example. I have a very good baseline for my 200 Newton thruster. Of course, it has to be tweaked, but then you can scale, also enabled by the additive manufacturing technology. So this is and the testing hardware. I think it's the 2 points which really can you make fast, and don't put, I don't know, millions or millions in the development of another thruster.
Yeah. And who was the first customer who said, I believe in you, I'm gonna buy from you?
I believe in the two founders. Give them money.
Yeah. We had an Australian customer. They ordered a CubeSat propulsion system, our 4U system. It's also all public. It's a saying a section spin-off part of a university, Australian university. They want to fly a mission to the moon later on, do some measurements there, some experiments, some science. And they said, okay, guys, you have unique capabilities. Your thruster unique capability is that those thrusters can fire as long as there's propelled. So, I mean, they don't burn through. And to have we call it thermal steady state. This thermal steady state capability is very important for a customer, because imagine you have to shut down your thruster every 10 seconds because it gets too hot, and then you have to wait, and then you have to fire again. So we demonstrated this already at DLR for this and a smaller thrust size, and this gave us a lot of credibility, because we had it in a vacuum environment, really with high fidelity test facilities, and demonstrated this already. And those Australian guys, they had a guest scientist at DLR, and he was visiting us, and he saw what we are testing, and they screened the market and saw what competitors can offer. So they said, okay, guys, you demonstrate here something. You're just founded the company more or less, but it's more than our current system can deliver. So they switched from their current system to our system. So this was the story.
Super cool. Really, yeah.
And offering capabilities the customer needs. So that was at the end the thing.
Yeah, and I think what you're explaining is I think this story can be replicated 100 times for other industries and other use cases by all these research institutions you have, because there's so much money in testing and so much money in development. So this sounds really like a blueprint of what we should see more often.
And then you mentioned Sebastian Klaus, right? And in our podcast, I think he also mentioned that he's buying from you. He was the one recommending you for the podcast. So what convinced him then to go with you?
At the end, the same technical factor I just mentioned. So we met Sebastian earlier. He was also part of Isar Big here in Baden-Württemberg.
Yeah.
So we met there initially. Then he told, I know him when he had his former company, Klaus Space Transportation, before Atmos was there. And then we talked, and I told him what we're doing. We're going to spin off. And then we talked about the capabilities. He has a deep knowledge of the space sector. And of course, he is a really great guy. And I said, hey, if you want, you need for your capsule some trust us, we can offer you something. Yeah. Then we said, okay, let's keep in contact. And at the end, what they did a trade-off analysis of all the propulsion suppliers, and this feature, like having those steady-state capable thrusters, where we can do this long burn to get their spacecraft back from space to a precise place on ground. This was the thing which, at the end, convinced them from a technical level. But I mean, you have to ask him. I think what is important for us as well is to be quite flexible and make the things possible for their specific spacecraft to really integrate the system according to their needs. And there we always trying to improve the products. And I think this is also important.
Yeah. So while there are off-the-shelf products, you do some custom adaptations to them.
Typically what we do, we talked about is CubeSats. There we have the standardized system. It's all standardized. So we have also standardized system. More or less, they will be plug and play. For the spacecraft like Atmos, what we have is like, we have standard building blocks. So we have like this three size of tanks where we have the thrusters I mentioned, the thrust glass. We have some interconnections there and the valves, and then we have standard building blocks and build a system together. In case, of course, it depends on the customer. There are always some part of tweaking to the customer's system or spacecraft. The larger you get, and if then at one point you have a very specific spacecraft, then of course will be much more customization. But that's the approach we are following.
Yeah.
And I mean, I don't know if you see my T-shirt. If you are an OG in new space, that's a PT Scientist
great
T-shirt.
Great.
And I remember when you were
great.
one of the first employees.
Yeah.
And back then you guys bought propulsion from Airbus, I think, right?
I think the idea was to buy the propulsion system from Airbus. Ultimately, I still remember there was a lot of debate around like where do you get it from, and it was such a different environment because you needed to deal with like former Soviet suppliers, and like because there was such a small market for propulsion you could look at, and they were all like all state-owned or state-like players. I was really like, yeah.
I think you wanted to use the same from the ATV.
I
think A8
Yeah.
of these from the ATV.
Yeah.
So now that's why PT scientists may also have failed because the supply chain was not there. Today it would be different, right?
Exactly. I just also heard from some space people saying it would not be possible to build those companies 10 years ago because the supply chain in Europe was not just there. That's also what really emerged in the last years.
Talking about supply chain and demand signals, we now have seen the ESA record budget, right, with 22 billion, with Germany's contribution of 5 billion. We have also seen the announcement from the German Ministry of Defense with 35 billion over 5 years. People ask themselves about where is this supply chain coming from, and you could supply. So would you consider yourself being a dual-use company or even defense, or how would you see yourself?
I think from the saying general rules and regulations, this was always, I mean, in our case, propulsion was always a dual-use good, as it was also when we dealt with projects at DLR, we always had to be aware of those dual-use applications. And of course, now it's for us as a subsystem and critical subsystem supplier, of course, it's very interesting. And we see a lot of requests from the saying defense side where we see that this spacecraft, I mean, we're building the propulsion system for a dedicated spacecraft. And in those military contracts, they always need a lot of agility, responsiveness. So you need to move quickly. There are hostile spacecraft approaches, you need to go away, or you want to inspect another satellite. All those saying in orbit services you want to do, saying in the civil application, those military in orbit service you need a capable propulsion system, which is powerful, fast, and precise. And that's really where we see a lot of requests incoming currently. Let's see where it brings us, because of course it's nice to support also to see those Apollo moment which is happening in Germany finally, how it was also called.
Yeah, I mean it is historic, right? With the current political momentum for European and also specifically German new space. I think it's exciting to see, but also it is dual use. It's not defense. It is dual use, and we also see a lot of more satellites in LEO, which also need to do collision avoidance maneuvers, etc. Right? So everything is getting more and more agile. I can see why your investors invested.
Yeah, I mean, the point is, Daniel, you said there was like when I started at DLR, like 10 years ago, the saying was, oh, 75% of future satellites will be all electric or electric propulsion. But speaking about the differences, now this didn't come true because the launch cost dropped so significantly. If you can have a chemical propulsion which is not so efficient, so that means at the end it's heavier or more mass. If the launch cost dropping, then at the end those efficiency gain you have from a very efficient propulsion system doesn't count anymore if you have a lot of other drawbacks. So we see, like especially with those responsiveness context, a lot more interest on chemical propulsion, and also with a decreasing launch cost, it got a really push for the chemical side. So that's what we are experiencing.
Yeah. And these overlaying, or when these multiple trends are overlaying, it becomes very difficult to project the future, because then like the easy answer is, yeah, launch is expensive, therefore something else will be the winning technology. But if you have multiple trends which are colliding and overlapping, you need to have a very good understanding of the industry.
One thing I want to say here is, at the end, if you invested in an electric propulsion company like Morphospace, you will win. If you invested in ISP Tech, you will win, because there's demand for both. We see this also in other industries, also in Earth observation. What's the right approach here and there? At the end, the macros, everything is moving up. So there will be winners in all these domains. It's not either or. I think that's what we see right now. 100%. And you are key driver now here for.
Also, what you see in other industries, definitely fully agree, Daniel. You see the technology has to serve the customer's problem, and then if the problem is large enough and there's a lot of people having the problem, then you can serve it on different ways.
And the entire industry is doubling or tripling now in the next years, right? So that's huge. Maybe last question about ISP Tech, and then we talk about the ecosystem a bit, coming closer to the end. You mentioned you have seen you can build a small company maybe with CubeSat propulsion or so, but you said you have seen something different. But how would you see your vision for ISP Tech, let's say in 2040? Where do you see your company being?
Yeah. I mean, our vision is that we provide every spacecraft with a suitable propulsion system, that we will be the propulsion company. That was always our goal. That means, really, when we think in the future, to make all those mobility in space so convenient as you can imagine. You just have to really have plug-and-play propulsion solutions with autonomy, for example, on board. As a satellite, I mean, you satellite operator, or as a satellite manufacturer, I don't know, the operator just wants to get from A to B. The spacecraft needs to go from A to B. And how can we do this much, much more convenient than it's today? To not have complex operations, to not have anything like that, to just, I mean, at the end, command the propulsion system. I want to go from A to B. The most efficient way is possible, or the most fast way, you can just select, like you're in a navigation system. And then the propulsion system does the rest, is very reliable, robust, and you don't have to think about it, you don't have to care the propulsion technology. And then, of course, those emerging technologies, like having the systems ready for refueling. You see, there are several companies doing it. Having all the ecosystem, and also allowing with that those in-orbit services, which will be a thing in the future. I'm sure about that. No one knows when it will be there, but it will come, and to enable this really. Because I always said, also saying that infrastructure in space will be at the enabling layer, technology layer, like infrastructure from getting to ground up into space, the rockets, is critical. But then when you are in space, you have to get from there to A and B. And therefore, mobility solutions for in space will be the thing of the future, the next step.
So then also the idea is to develop more software layers on top of the hardware, it sounds like.
Exactly. When we see now working with our customers, we see, okay, they have to do their onboard computer and they have to interact with our propulsion system. We have our own electric control unit, and we're already developing this to be much as convenient as it could be. Because when our electronics supervises all the tank pressures, the system, and so on, at the end, the customers should just say, okay, I will now move from here to here, and that's it. Like if you're in your car, you don't have to think about injection velocities, or I don't know, or throttle, or you just put the pedal, and your car goes. This should how propulsion should be.
Nice. Yeah. I also just see how connected everything is, right? We as LiveView need more satellites. I've seen one of our investors, MetaWave, They invested in Okapi Orbits, which is doing space traffic management for collision avoidance, right? But they also invested in Infinite Orbits, which is doing in-orbit servicing. And you just mentioned in-orbit servicing, right? So it is just showing how this ecosystem also in Germany and Europe is thriving. I'm excited.
Yeah, super
I
excited.
haven't seen that coming, but it's crazy. Yeah.
Very, very cool. Maybe final note, right? You've mentioned that you've obviously got VC funding in the past, and it's also like some of your investors are listed on your website. How would you say the funding environment is in Europe versus in other parts of the globe? And would you say that this is structural disadvantage or advantage in Germany versus like some of your peers and competitors in other markets?
In general, I still think that space is not considered such a thing in Europe in general, like it's in the US. Still, I mean, people now realizing it more and more, but also from the investor side, I think there's a lot of saying vague vision or thing about space. People seeing like Starship launching and landing or something like this, and imagine, oh, that's how space business works, and see that SpaceX is the most valuable company, but that's really just a top level understanding. And what we see from the environment in Europe, still people think that space is interesting, but they can't grasp it, and therefore they are reluctant to invest, for example. So I think it's also something you experience, and then you have to educate them and to say them the specific needs of the market. And what we also see from those institutional markets, a lot of people still have those, space, it takes 20 years and costs billions mindset, which is changing. And this then in comparison to saying a little bit more reluctant funding environment in Europe, that doesn't help then to really get to speed and to really do those breakthrough commercialization of space or do those breakthrough activities, which is a pity. We're always saying when we're in the US and to have the same status, you would have the funding would have like 10 times the funding, because I think there's still some gap. I see that it's changing.
Yeah. Well, we're all working on doing that. The podcast here hopefully also plays a very small role in educating the market about what cool things you and others are doing. So I also have to say it's really exciting to see how the ecosystem is working together and how many cool things are happening in parallel. It's really incredible.
I mean, honestly, what you mentioned, guys, I really appreciate it that the space ecosystem is so well connected. We know each other. We can look for opportunities together. The founders are well connected. I just had a talk with a founder, and we're exchanging about VCs, some investors, exchanging about people in the sector and business opportunities, and this is really great. I mean, I love this that we have such a strong founder network in the space industry.
100%. And I think like Danny and I, we could talk for hours. The good thing is that we, as you just said, likely will come across one another in the not so distant future at one event or the other. But that being said, as we have you here on the podcast for one reason, because you've been recommended by a previous podcast guest and because we've met at a conference, we wanted to ask you, who should we bring on to the podcast the next time?
That's a very good question, because I had someone in mind, which I just learned you already said. Do you looking more for founders, or are I also have some people from the investor side?
Investor side is also great. Yeah, anyone who's like related
because
to the space.
Then just what's popping up here, to be transparent, our investment manager at HGGF. Yeah. He is really a space guy. Probably you know him, Kuhn Gertz. And he is really a space guy. He was working at a Rosetta mission in the past. So he really was building spacecraft to land on or to address and to land on comets. And he really knows the sector quite well. For many years was working at Telespazio for many years there, also the management. And so I think he would be a great guest to see also like the investor side and space business side.
Yeah, I think that would be perfect. And he's a cool guy. I've met him already, and I think like he would be a perfect guest. So definitely gonna take you up on the offer of making the intro there to have him on our podcast in the very soon future. Nice.
Yeah. Unfortunately, we are at the end of the podcast. We even did a couple of minutes more because it was really exciting. I think like talk about Lampoldshausen. We could do an entire podcast. A city no one knows.
You have to come over. When you're in the southern of Germany, we go to Lampoldshausen, and they have a beautiful museum.
Yes, let's do this. I would love to see some tests at some point in time. But yeah, thanks a lot. And for our guests, for our listeners, I hope you also enjoyed the the session today. So make sure to connect, to follow ISP Tech and also Lukas through all the socials. Check the website. I don't know if you have jobs open. I assume so. Yeah. Really cool company. And yeah, Lukas, thanks a lot.
Daniel, Sven, thank you so much. This was great.